Hello. Today we're going to be wiring up our operational amplifiers to work with our ESP32. Let's get started. Okay, so the operational amplifier that we're going to be using is the L272AM. The L272AM is a power amplifier, which means it can source about 700 milliamps of current. This is enough to drive our two little DC motors in our basebot here, and so that's what we're going to be using it to do. We're going to use the analog outputs, the digital to analog converters on the ESP32, and we're going to use that to drive a signal into our amplifier in order to get it to run the motors with a given speed. Now, the way we're configuring this, the motors are only going to spin one direction. If you wanted to get the motors to spin both directions, you just need a little linear regulator at about half the voltage range, so 1.65 volts for half of our 3.3, and you would use that as the reference for the motors instead of ground as we have them wired up here. So one side of the motor is connected to ground, the other side is connected to the output from our operational amplifier. Now, our operational amplifier is going to take a signal from 0 to 3.3 volts, and it's going to drive the motors with the same 0 to 3.3, except coming out of the ESP32, you can only do a couple milliamps. Coming out of this amplifier, you can do 700 milliamps. So that's going to amplify the amount of power that our system can drive. So let's take a quick look over at the data sheet for our wiring diagram of our chip, and the circuit diagram that you can see here in the drawing package. So first thing that we're going to do is actually not wire the amplifier. We're going to wire up a potentiometer. So potentiometer is going to be used for our testing, and we're going to use that to get everything started. We're also going to wire the ESP32 and use that to provide our 3.3 volt rail, which we don't have otherwise. So first things first, we're going to start by beginning to actually test everything. So we have our two little wires plugged into our USB port here, and according to our diagram, we want to just make sure that we have enough of our circuit built so that we can actually test as we go. So let's pop over to our testing window. So first thing we're going to do is I've taken my probes from my multimeter and I wrapped a little bit of wire around it so that we have a nice isolated connection, so we can stick our wires into the breadboard. The same thing with ground. So you just wrap it around a couple times and use the bare part of the wire to make a good electrical connection. So we're going to plug one side into what I assume is going to be 5 volts and the other side into what I assume is going to be ground. We'll note that the meter doesn't say anything yet because we haven't plugged in our USB. And if we plug in our USB, we should see 5 volts on our meter. Let's see if that's what happens. Good. 5 volts on the dot. Great. So, next up, let's start building our circuit. So the first thing we want to do is make sure all of the grounds in the system are going to be connected. So we're going to take a little wire here. We're going to plug it into the ground pin on our coming off of our USB port, and we're going to plug it into this wire, this port here. Now, the reason I put it into this pin first is because we're going to have a little potentiometer sitting right there, and we're going to use that ground reference for the potentiometer. Then we're going to jumper from that pin over to the ground rail on breadboard. As you can see here, we've got a little green wire right there, and now we have our ground for the system here, and then the ground for our potentiometer. Now, like I said, we're going to use our this little potentiometer. Stick a little piece of double stick tape to the back of it. Peel that off. Use the hobby knife to trim it up. Great. going to stick this into the breadboard like so. Now we should have good mechanical connection for our potentiometer, and the ground pin should be connected. Next up, we're going to do the 5 volts for our potentiometer, or sorry, 3.3 volts, I apologize. So this rail here is going to be our 3.3 volt rail. So nothing is providing that 3.3 volts yet, but we'll get that in a minute. That one's a little too short. Now remember, with jumper wires and with breadboards, you always want to use the shortest possible wire. And you should never have wires sticking up in the air above your breadboard. Every wire should be completely pressed into the breadboard and touching. They can jump over other wires, and that's fine. But they should not be sort of sticking up in the air. See how everything's nice and flush against the board? Good. So now we should have a voltage divider made by our pot. Great. Well, how do we provide power for that? We're going to need our ESP32 to provide that power. So the first wire that we're going to add is one that's actually going to sit underneath our ESP32 once it's installed, and it's going to go from the 5 volt rail, which is the red rail over here. You can see we already have our 5 volts connected to it, and we're just going to jump right over to the last pin in the row. Because when we put our ESP32 in, like this, that last pin in the row is our 5 volts pin. Notice with the USB port going this way and the USB port going that way. We want to make sure it's hanging off the edge, and note a row of pins do hang off the edge in this setup, because if we put it in the middle, then the USB port would hit the wheel and we wouldn't be able to use it. So this one we're not going to put tape on. We're not going to put the double stick tape because sometimes you want to pull this thing out and use it in another project. So this is going to be the only one that we don't put our double stick tape on. However, once we have the wire underneath plugged in, we can just press our ESP32 into place. Good. Alright. So now we have 5 volts going from here to our 5 volt pin. Our 5 volt pin is providing 5 volts back to our circuit. Now we also have a 3.3 volt pin, which is on the other end of the ESP32. We just need to get that over to our 3.3 volt rail. And again, we're always going to pick the smallest wire possible to do the job. So I can't do it. Nope, off by one. And it might not be the most logical color to use, but if it's the right length, that's the right wire to use. Alright, so we're going from our 3.3 volts here into the 3.3 volts there. Now the last thing we need to do is add our ground wire to go from the ESP32's ground to the ground pin on our rail. So the ground pin is labeled right here. And pop that in there. And pop it in there. So now we should see ground on the ESP32, ground on the USB port here, and ground on the pot all connected together. Let's make sure that's true. So we're going to come over to our meter and switch it to the beeping ohm mode. Nothing else, no power is plugged in. I'm going to plug one side of the meter into our ground rail, and we're just going to go ahead and check ground pin here. Beep means it's connected. The ground pin here. Beep means it's connected. The ground pin here. Beep means it's connected. And then we're going to check for dead shorts. Check to see if the power rail is connected. It has some, there's a Thevenin equivalent resistance of the circuit there, but it's not dead short. Good. Check it over here. Check our 5 volts, see if that's dead shorted. Good. So now we know our 5 volt rail is all connected. Our 3.3 volt rail should be all connected. Let's check and make sure that 3.3 is connected to the 3.3s. So we plug our one side of the scope probe into our 3.3 volt rail, and just sanity check by plugging it in. And check this pin on the potentiometer, and check the 3.3 pin over here. That looks good. And then check to make sure that's not connected to our 5 volt rail. That looks good. Alright. Looks like we're good to do a power on test. So I'm going to move the common connector of our multimeter over to ground. Switch the multimeter back into voltage mode. And the first thing we're going to check is our 5 volts on the system. So I'm going to plug in our USB connection here. And you can notice that it's not exactly 5 volts. Why is that? There is a diode on this module so that if you provide 5 volts here, it won't fight with the 5 volts here, so that there is essentially, this is on the other side of the diode. If we were to unplug the USB here and plug it in on this side, you should see that full 5 volts again. Alright, good. Now, we're going to stay connected like this, and we're going to check our 3.3 volt rail to see if it's at the right voltage. That looks good. Alright, now we're going to check our potentiometer. So I'm going to take the probe and I'm going to plug it into the middle pin of our potentiometer. Now when I turn the pot, it should go from 3.3 and turning all the way down to 0. Good. Alright. Now wired up our 3.3 volt and 5 volt rails and our ground pins. Let's power down and add the op amp. So when we look at our op amp, we have a little notch up at the top of the chip. We're going to use this little notch to match to the little notch in the diagram. Focus. Alright. So now, we're going to take our chip and look for pin 4, which is on the left side, all the way down. And we're going to plug that into the same rail that has our ground pins already. Because why wire it up again? Alright. So now, we drive our system with the 5 volts, not the 3.3 volts. 3.3 volts is very low current. It's for sensors. We don't want to drive our motors with that. So we want to drive the motors with the 5 volts. So our VCC for the system, pin 2, otherwise known as this pin right here, is going to be connected to our 5 volt rail. So what's the shortest distance between this pin and the 5 volt rail? It's this little jumper here. So we're going to find one that should fit that gap nicely. And we're just going to plug it right in. Alright. So now we have VCC connected and ground connected. Great. So let us take a look at our diagram and see what else we need to connect. So first things we want to do is see that there is a wire connected between in 1 negative and out 1. So in 1 negative is pin 8, which is this pin all the way up in the corner, and out 1 is pin 1 right here. So we're just going to take one of these white wires and we're just going to run it right across the top of the chip. Alright. So now that's our in one negative to our out one. And from the op amp's perspective, that sets it up as a voltage follower. So whatever voltage is set to in plus on channel 1 is that same voltage is going to be matched on out 1 with a higher current. Cool. So now we're going to wire up our the other side in 2 negative, which is the pin down at the bottom, to out 2, which is that pin right in between there. So we're going to go ahead and grab another wire. And this one we're going to bend ever so slightly, so that when we plug it into our out one there, and our in one into negative, and our out two are connected. Great. This is coming along swimmingly. Next up, we're going to have 2 big loopy jumpers. Now these big loopy jumpers are going to break the rule that I told you before of going up and over, and the reason is we want them to stick out as something that we're going to remove later. So this is the output from our potentiometer, and we're going to put that into in 1 plus and in 2 plus. The reason we're going to do that is because before we connect our ESP32, we want to test everything with our pot. So the voltage coming out of our potentiometer is going to be used as the reference voltage going into our operational amplifier. But this is just a temporary connection. So these 2 big red wires here, we're going to remove those later. Okay, now that we have the majority of our circuit built, we're going to add the last little piece, which is the motors themselves. So the motors go between out 1 and ground. So let's take a look at what that looks like. So we've got one of the motors over here. So let's 2 wires out. There. Good. One of the motors over here, and it's going to go between ground and it's going to make the right motor 1. So that's our out 1. And then our left motor there. And our left motor goes to out. You know, I'm realizing it would be easier if we just ran these wires for the motor on the other side up through the middle. So that's what we're going to do. There. And we're going to move it and put it right there. So now we have our 2 wires for the 2 motors driven from the operational amplifier using the potentiometer as their inputs. Sounds good. So let's see what happens when we power this up. So we can power everything from the 5 volts. And what we should see is, as we turn our potentiometer, the motors begin to spin. We turn the potentiometer all the way up, the motors spin all the way up. So let's turn it all the way down. And let's get a voltmeter on that and check, make sure everything's working correctly. Alright, so first things first, we want to see the output from the potentiometer. And you can see here at about 0.2, 0.3, 0.5, at about 0.85 volts, the motors start to begin to turn. And then as we turn them all the way up, we should see them spin at full blast. And if we turn them back down, there we go. So that looks good for being driven by the potentiometer. Great. So next up, we're going to remove our two little wires here after unplugging the power. And we're going to begin to build the circuit where the ESP32 drives them. So according to our diagram, we should have I/O pins 25 and 26 connected to our two motor channels. So the two driving signals come from the ESP32, pins 25 and 26. So let's go find those two and wire them up. So first things first, we find pin 25, and you can see it from the silk screen right on the label there. And we're going to run that with a slide bend into input 1. So 25 is input 1. Good. And then we're going to do, so I'm going to leave a little bit of room so that the next wire that comes in can be directly follow the same path to one pin over. So you can see here, these two pins now follow the same path. Great. So, how do we get these to move? Let's switch over to our programming interface. I'm going to create a new Arduino sketch. I'm going to call this line track. And see. So create new sketch. And call it line tracker. Forgot I had already set this up before. And I'm going to use ESP32. That looks good. And we're going to uncheck the sample sketch. We're just going to use a default INO file and hit finish. Cool. Look at that. So all that we're really going to need to do is check to see that our DAC is working. So we use the built-in DAC write function, and we're going to use pin 25, and we'll start by setting it to the max value, 255. And do the same thing on pin 26. And we're just going to delay. We're going to do that for about 1 second. And we're going to then write it to 0 for both. And it's going to loop. So what this is going to do is go full blast for a second, and then off for a second. Great. Let's get our ESP32 wired in. Uh-oh. Make it run for it. So you'll notice, by plugging it right in, the default state for these pins is not stopped. So you gotta be a little careful while programming. Hold it in your hand while programming. I'll go ahead and give that a quick program. So, the first time you compile the ESP32, it takes a while to compile its dependent libraries, but after that, it uses the compiled binaries, and compilation is much, much faster. So, a keen eye would have noticed what I have done wrong here. So, let us unplug our ESP32. I have plugged it into pin 25 and 33 instead of 25 and 26, which are the two pins next to each other. So it's an electrical wiring off by one error. Let's see if this now behaves the way we're expecting it to. Good. Excellent. So the next thing to notice is that since the line tracker is going to go this way, and since the wheels can only spin in one direction, one of these wheels is spinning the right direction and one of them is not. This one's spinning backwards and this one's spinning forwards. So to correct that, we simply take this motor and reverse its two motor wires. So again, never unplug wires while the system is powered. And we're going to pull the positive wire out, plug it in to the ground pin here, pull the black wire out, and plug it into the I/O pin here. Now, we should see both motors spinning forwards and backwards. Forwards and stop. Forwards and stop. Excellent. So, next up, we want to test our analog sensors. And we're going to need to read them in the ESP32 code. So, first things we're going to do is include the ESP32 analog read library. Give it a second and we'll find the library. And we're going to make ADC objects for our line trackers and our pod. One sensor left. And So we have our sensors here. So we're going to attach the left sensor to pin 33. And attach the to pin 32. I'm just kind of going in order along here. And we're going to attach our tuning pot to pin just so everyone can see what I'm doing here. So you see there 33, 32, 35, 34. Okay, so that's 35. All right, so we now have line sensors and a tuning pot that we can read from. So from here, I'm going to just do a quick serial .write on all of our values to make sure that we're capturing everything in a reasonable way. So we're going to take our line left, read voltage, and we're going to divide the voltage by 3.3 to get a 0 to 1 value. That 0 to 1 value is helpful for doing math with later. Oops. Tuning pot. Voltage 3. So now we have our 3 values, and I'm just going to go ahead and comment this out for now, and we're going to just print out our 3 values. So all right. And then finally, we just want to delay this loop by 30 milliseconds so we don't hit the print statements too hard. All right. Now we're just going to go ahead and hold up our robot and plug it in again. And we're just going to program the simple sensor prints. The motors continue to spin. So, real quick, I'm going to unplug my two motors, and I'm going to connect them with this jumper cable. So the first thing I'm going to do is grab a couple pins of a header, stick it in somewhere in the breadboard. That doesn't matter too much. And I'm going to connect one side of this little jumper header to my ground. And the other side, I'm going to plug in the two motors. And now I have a handy dandy jumper which can turn the motors on and off. So for right now, we're going to leave them off. It's like a switch. So the one other thing I want to do is right up at the top of the code here, I'm going to turn off our motors so that by default the motors won't just start running. The last thing we need to do is we need to connect our tuning pot and sensors to the correct pins. So we sort of claimed that they're connected to these pins here, 33, 32, and 36. So we need to make sure that that is in fact true. So now that the programming is done, I'm going to unplug the USB, and I'm going to take a look at my left pin. So left, this sensor here is needing to be connected to pin 33. So line left to pin 33. Good. Line right to pin 32, which is just right next to it. And then finally, we have our tuning pot that goes from pin 35 all the way over to the center pin of our tuning pot. Good. So now, if we plug in our ESP32 and we fire up the serial monitor, should begin to see our print statements coming through. But I of course forgot to do a serial.begin. One 5200, which is why nothing was coming out yet. So we'll do one final program, and we should start seeing values coming out of our sensors. All right, so now we've got my two sensors hanging out, and when I put the sensor over the line, it goes from about 0.4 to 0.7 to 0.9, and then when it comes off, back down to 0.4. You can see the other left sensor going from about 0.4-ish up to 0.9. Good. Now let's check our tuning pot. See if we can go from 0.04 all the way up. Our tuning pot appears to not be on the pin that we think it is. I'm just going to switch the tuning pot to pin 34 because I can read that label more clearly. And then, because I wrote it was 35, and I should probably write 35 into the IDE in order for that to work. So let's go ahead and program it. We'll check our tuning pot again. Wonders of modern technology. The numbers have to match. Alrighty. So now as we turn our tuning pot, it goes from 0.93 all the way down to 3. Now, you'll notice that it never gets all the way up to 1. Why is that, you might imagine? Because the analog to digital converter on the ESP32 does not do 0 to 3.3. It does 0.1 to 3.1, which means the actual range for our sensors is a 3-volt swing, and it should be scaled with dividing by 3 volts instead of 3.3. So let's do an upload sketch and see if we get values that make a little bit more sense. Ah, 1.03. Why is that? Because we didn't subtract our offset of 0.1. So we want to subtract 0.1. Good. So now we should see our ranges a little bit more understandable. Good. All right. So you can see our sensor as it goes from on the line to off the line has a swing from 0.26 up to 0.99. And our tuning pot comes down from 0 to 1. Excellent. All right. Now, you know how to drive the motors with your ESP32. You know how to read the sensors and a tuning pot with your ESP32. If I were to give you any more information, I would be doing the lab for you. Thank you for watching.